This one here is the bloop sound. Blue whales are, even though they're the loudest animal we know in the ocean for a continuous sustained sound, they're nowhere near as loud as the bloop sound. We can hear the bloop sound for thousands of miles. The animal would have to be gargantuan if it were a biological sound.
To find out what produced the mysterious sound, scientists had to consider the impossible. Perhaps blue whales are not the largest creatures in our oceans.
It would be something completely unknown, and it would probably have to be huge. And you have to say, well, how could something that huge be totally unknown on Earth?
You know, there's no question. We don't know what's at the bottom of the ocean.
The only other animals comparable to whales were from prehistoric times. Could the sound have been produced by an unknown creature that survived to the present? In 1938, a coelacanth was caught off the coast of South Africa. They were believed to have been extinct since the end of the Cretaceous period, over 65 million years ago. In 2006, the remains of a previously unknown prehistoric marine creature were discovered. Named Predator X, the creature was 15 meters long and would have weighed 45,000 kilos. Is it possible that these creatures still exist?
It's possible there's some creature out there that we haven't found yet. I'm skeptical of that idea because I think we would have fished one up in a net by now.
What makes it questionable as to whether it's a biological sound was it was only recorded once.
So if the sound wasn't made by an animal, what else could have made it? Experts are trying to uncover the origins of a mysterious sound that came from deep within the Pacific Ocean. They believe it wasn't made by an animal, so another theory emerged. Could the bloop have been produced by something geological? The outermost layer of our planet, the lithosphere, is divided into tectonic plates. Earthquakes and volcanic activity occur along their boundaries. It's estimated that millions of earthquakes occur each year. Like volcanic eruptions, most take place deep under the Earth's oceans, producing massive sound waves.
This is the sound of a resonating volcano, and it's all very low energy here. It's almost like a little white-yellow band there. Again, here's an example of an earthquake, and it's all low-frequency energy.
But when the sounds of the earthquake and volcano are compared to the bloop, there's one important difference.
What's different about the bloop is that it's at a much higher frequency range, much higher pitch than these natural sounds.
Could it be a more unusual geological sound? The bloop was recorded near Antarctica. Is that a clue to its origins? The effects of global warming have increased the number of giant icebergs breaking off from the Antarctic shelf.
We see really bizarre sounds coming out of Antarctica that are caused by the interaction of these giant icebergs coming off of the mainland. We see the sounds of ice cracking. We call them ice quakes. That's very distinctive too.
The sound of icebergs breaking can be as loud as 193 decibels.
Icebergs can be as big as, some big landmass. It can be 10 miles wide, and they can make ice quakes that are comparable in size to earthquakes. On this one is the sound of an iceberg tremor. The icebergs moving along the seafloor, scraping along the seafloor, causes the iceberg to resonate and makes a harmonic sound.
But so far, none of these recordings have captured a sound similar in frequency to the bloop. Is it possible it was man-made? Could the very people who helped Dr. Fox with his project be responsible for this mysterious event? In 2000, dozens of whales beached themselves in the Bahamas. Residents believed it was caused by tests of the US Navy's classified sonar used for marine navigation. It's estimated that some sonar transmitters can generate sound as loud as 215 decibels. Could this explain the bloop? Or was it a secret military test?
They were putting devices and instruments in the water, testing underwater explosions, doing underwater experiments of various kinds.
I don't necessarily believe in conspiracy theories. I think there's probably a reasonable explanation for all the sounds we observe in the ocean.
Despite the numerous theories, no one has proved what caused this mysterious sound. But scientists are hoping it will be heard again. Perhaps then, its origins will be revealed.
Will we hear it again? You know, will this sound reveal some new mystery of the ocean?
Sometimes extraordinary mysteries are found in the most unlikely places. In these quiet pastures is an animal that may hold the key to one of the mysterious forces of our planet. It's a mystery that's had the world's scientific community baffled. The animal in question? The cow. This bizarre story began in 2008 when zoologist Heineck Bürder was analyzing satellite imagery of the Earth's pastures.
We looked at several thousand pastures and several tens of thousands of animals.
What he found was remarkable. Across the world, in Europe, Africa, and North America, hundreds of millions of cows were facing in the same direction, either north or south. Heineck thinks he knows why. He believes that cows may have the ability to perceive the Earth's magnetic fields. Now, for the first time, researchers are going to try to prove if this power exists. Heineck thinks he's discovered the answer to this mystery. He believes that cows have a power called magnetoception.
Magnetoception means that the being can really see the magnetic field.
Our planet is essentially a giant bar magnet. Inside, a hot liquid iron core is moved around because of the Earth's rotation. It's theorized that this motion creates the Earth's magnetic fields. Magnetoception is the ability to perceive these magnetic fields, like a compass. Experiments have shown that a diverse range of animals, from birds to bees, salamanders to sea turtles, have magnetoception. But so far, this ability has never been found in large mammals like cows. To test his theory, Heineck is in the heart of cattle country in Texas, where, with the help of some local cattle experts, he hopes to prove that cows have magnetoception. Jason Clear is a beef cattle specialist from Texas A&M University.
I'm not sure that, the data's there to prove or disprove it.
Jason Sawyer is from Texas Agri-Life Research.
I've been around cattle most of my life, and it was just sort of a natural fit for me to go into research.
Kyle Damborski is a Texas A&M physics graduate student. He's been commissioned to build a giant electromagnet to test Heineck's theory.
This is definitely in the area of weird science.
The electromagnet contains two sets of magnetic coils which are wrapped around the wooden frame.
Well, we have two coils. One's lined up north-south, the other's east-west. And based on the direction of the current that we put through the coils, it'll generate a magnetic field, and it's just like turning the Earth's magnetic field.
Sending electricity through these coils will create magnetic fields in two very specific directions. If the cow rotates and aligns with them, like a compass needle, there is potential evidence of magnetoception. The magnet will generate a field twice as strong as the Earth's magnetic field. If Heineck's theory is correct, the cow should align with the man-made magnetic poles. The experiment begins as Kyle moves the machine's magnetic north due east. But the cow appears unaffected.
The animal just seemed to continue to do what he was doing. He kind of continued to sniff around. He seemed to get a little bored, saw the grass on the other side.
It seems that external factors like being hungry can influence the cow.
I think that cattle in general are probably more complex than most people give them credit for.
Perhaps external factors are a clue to solving this mystery. Could it be that cows prefer to face north or south because of something as simple as weather?
If we get a really cold norther that blows in, cattle will turn their rears to it.
If a prevailing cold wind is coming from the north, the cows would turn away and face south. And since cows tend to huddle together to minimize heat loss and exposure to the elements, it would appear that the cows were all lined up in the same direction.
The other thing too is if we get a really cold day, the sun pops up, they're going to try to position themselves to get more of the sun on the side of their body, more surface area.
Could the fact that the sun rises in the east and sets in the west explain why cows all face north or south? Hynek believes they will still do it, even on an overcast, windless day like today.
Experiment number 2.
Coil 1's at full power.
Hynek's second attempt is no better than the first. Cow number 2 doesn't react to any change in the direction in the magnetic field.
It looks like these bulls are possibly moving to the feeder at the back of the pen, and this one is more or less feeling left out.
Experiment number 2 is a failure. It seems that cows prefer to be in herds. Could this be the reason why they're aligning themselves north or south? These cattlemen believe this herding behavior might be contributing to their alignment to the magnetic poles.
Herd animals in general, and cattle in particular, exhibit a fairly intricate social structure within the group. If the lead cow is pointed in a certain direction and traveling in that direction, you'd say that at least the majority of the rest of the herd is also probably going to be oriented more or less in that direction.
So if the leader is facing north, so would the rest of the herd. But Hynek thinks it's likely that herd animals like cows use magnetoception to help them navigate as a group over large distances.
The only explanation is the magnetic field.
After 2 failures, the zoologist has one last chance to prove his theory.
Let's shift the magnetic field for 90 degrees to the east. We shall see what happens.
Okay, you're east.
It's a good start. The cow has aligned east.
Let us confuse the animal a bit more. Let us shift the magnetic field in the south.
It appears the cow's reacting to the magnet.
So actually, now the cow aligned again with the predicted direction.
They're going to do it one more time to be sure.
All right, you're west.
Does this mean the experiment was a success?
I have seen some evidence that these animals reacted on changed magnetic field conditions.
But to find out if cows really do have magnetoception, more experiments will need to be performed. If it's true, we may solve another mystery of our planet.